So before we begin, what are we going to do in this video? For this video, we are going to handle everything under the test 2, the 15 questions under the test 2. What we cover this year on test 2 is conic circles and kinematics. Those are the two topics we're going to cover today. This video or this live, basically, you don't need to watch the whole thing. You can, it's going to take a long time, possibly 2 hours, to finish solving this whole solution. So you can, go on to where you need. Because I know at this beginning part may be easy for most people. So you can still the ending part where I will begin to solve the kinematics question. Because I know that kinematics may be a battle for most people. Let me share this link to the groups so people can join the live. The first thing you need is the slope of the tangent. The slope of the tangent. Tangents. How do you get this? If you differentiate this, look what I'm showing this. If you differentiate what I want to do. If you differentiate this, those results. So if you put one, the other event will. So the slope of tangent is what? Slope of the tangent is what? You have only one point. You have the x. No, you need x and 1. And if you put this x is equal to 1 into the equation, which is f of 1. No, 1 squared plus we have just put 4. So the point is what? 1 comma 1. So the equation is normally what is y minus y1 n, right? X minus x. So this is y. What is y1?
No one is 4.
And then so you need, depending on the options that are given you to. Now for this normal. The normal is okay. I've shared the link complete so we can begin solving. Okay, question 1. Okay, before I begin, I'll just give the thanks to who thanks is needed. I want to thank Mr. Francis for giving me his office today. Let me do this video. Mr. Francis, do you want office? No. Okay, no face today. So I want to thank Mr. Francis for giving me the office to use to make this video. I want to thank the maths department, even though they're not around today. I want to thank, the lecturers for Maths 123 for this privilege to do this live. Finally, I want to also thank God for His grace. So, with no further ado, let's begin solving. Question 1. Question 1 says you should write the equation of the circle. We have 4x squared plus 4y squared minus 8. We have 4x squared plus 4y squared minus 8x plus 4y is equal to 103. This question says that we should write this equation in a standard form and we should determine the center and radius. Okay. The standard form for this type of questions is x minus h, rather A B C D F G H I A B C D G. Okay, x minus g all squared plus y minus h all squared is equal to r squared. It's actually going to be x squared plus y squared is equal to r squared if it's at the center. But if it gets shifted to the left, then you would have all those constants. If you get shifted to the right, you have all those plus one plus two plus three or minus one minus two minus three. If you get shifted upward, then in the y term you're going to have plus one plus two plus three. If you get shifted downward in the y term, you're going to have the negatives. But then this formula is only when it's at the center. So if you want to solve this, you have to complete the square two times. I didn't bring my duster. To solve this, you have to complete the square two times. And how do we complete the square? To complete the square, you are going to have an x squared term, you are going to have an x term. So all you have to find is the constant that will make that x squared term and x term a perfect square. You do the same thing for y. Now remember, whatever you're adding to the left hand side, you have to also add it to the right hand side to balance both sides. So let us begin. I'm very sure if you start solving, it will be easier to understand what I'm saying. Now, if we have 4x squared plus 4y squared minus 8x plus 4y is equal to 103, the first thing you should do is to make sure you have everything in terms of like x squared and y squared. You're not having 2x squared, you're not having 3x squared. It's just going to be x squared. So what you're going to do is to divide all through by the equation of x squared or the equation of y squared. So you're dividing all through by 4. If you divide all through by 4, you're going to have x squared here plus y squared minus 2x plus y is equal to 103 divided by 4. It's not compulsory, and I will advise against using decimal points, because if you use decimal points, it may become harder to add and subtract. So I will advise just use it in fraction. So you have x squared plus y squared minus 2x plus y is equal to 103 divided by 4. Now all the x terms or x squared terms to one side and all the y or y squared terms to the right hand, not the right hand side of the equation, but like just arrange them so the x is comes first and the y is comes next. So you have x squared minus 2x plus y squared plus y is equal to 103 divided by 4. Now let's complete this square. But before we complete this square, I want to explain how the completing square method works. So if you have x plus a all squared, this is equal to x squared plus 2ax plus a squared. Remember, in this bracket, we have the x squared term, good and fine. We have the a term. The a term can be gotten from this. Yes, we have the 2ax term. This 2x term is equal to this minus 2x, but we don't have this a squared term. So that's what I want to get. This a squared term, we're going to add it to both sides. Then we'll do the same thing for y. When we get the a squared term for y, we're going to also add it to both sides. So now how do we get this a squared term? You need to get this a squared term after you have found what the a term is. Now how do you get the a term? You compare your coefficient. If you compare your coefficient for x squared is equal to x squared, so there's nothing to do there. But 2ax is also going to equal to minus 2x. So there's something you can do here. You can cross multiply, you can cancel out the x from, you can also cancel out the 2's from both sides. So you have a is equal to minus 1. Another way to say this, you can say divide both sides by 2x. So you're going to have a is equal to minus 1. If a is equal to minus 1, this implies that a squared is equal to plus 1, because minus 1 all squared is equal to plus 1. Minus squared all squared is equal to plus 1. Yes. Okay. So now this a squared term that we got plus 1, you have to add it to both sides so we can complete this square in this bracket. So what we're going to do here is plus 1. And okay, let me just do the term for y also, so we'll just add it one time. If you do the same thing for y, you have y plus a all squared. There's no need for you to do all this y plus a all squared in the exam. Just carry this y term divided by 2. The equation of y here is 1. Divided by 2, that is 1 over 2. Then square it, that is equal to 1 over 4. But let me just do the long process so you see that the answer actually will give us 1 over 4. So you have y plus a squared. This is equal to y squared plus 2ay plus a squared. The same thing happens here. Y squared is equal to y squared. There's nothing much to happen there. You have 2ay is equal to y. 2ay is equal to y. As I say, divide both sides by 2y. If you divide both sides by 2y, you're going to have a is equal to 1 over 2. Remember, we're not looking for just a, we're looking for a squared. And a squared is going to equal to 1 over 2 all squared, which is equal to 1 over 4. That's the easier way of doing it. Find the coefficient of y, divide it by 2, then square it. So you have 1 over 2 all squared, that's 1 over 4. So now we're also going to add 1 over 4. We are adding this 1 because of after we completed the square for x, and we're adding this 1 over 4 after we completed the square for y. So we're going to just, in total, we're going to add one whole number, 1 over 4, that's 5 over 4. So adding 5 over 4 to both sides, plus 5 over 4 plus 5 over 4. We're adding 5 over 4 to both sides. I believe that's understood. You're adding 1 because of the x terms, and you're adding 1 over 4 because of the y term. Instead of saying plus 1 over 4, just add them together, plus 5 over 4. Okay, so here we have x squared minus 2x plus 1 plus y squared plus y plus 1 over 4 is equal to 103 over 4 plus 5 over 4. X squared minus 2x plus 1. Remember, we had x plus a all squared. Our a for x was a is equal to minus 1. So this bracket is going to equal to x minus 1 all squared. Or rather, you can just say it as x plus bracket open minus 1 because a is equal to minus 1, then all squared. But you still end up getting x minus 1 all squared. So you can replace everything inside this bracket with x minus 1 all squared. You can replace everything inside this bracket with x minus 1 all squared plus the same thing happens for y. You have y squared plus y plus 1 over 4. Remember, we had y plus a. Our a was equal to 1 over 2. So this will be y plus 1 over 2 all squared is equal to 1. Remember, as I said, it's easier to do everything in fraction than to change it to decimal. So you have 103 divided by 4 plus 5 divided by 4. Since they are the same base, you have 103 plus 5, which is 108 divided by 4. 108 divided by 4 is 20. 108 divided by 4, 1 year, 2 year, 2, 8, 7, 27. Okay, but this is not the end of it. This is 27 here. But what is supposed to be there is supposed to be r squared. So what we're going to do is to square root the left hand, square root the right hand side and square the right hand side. Remember, to hold equality, if you are adding something, you're also going to subtract it out. Subtract it out. Either you do that or you do it to both sides. If you're adding 1, you add it to both sides, or you add 1 to one side and subtract it again from that same side to maintain equality. So in this case, instead of squaring both sides or square rooting both sides, what we're going to do is to square root. We're going to square root that right hand side, then square it back again. So now we are now put it in that general form of x squared plus y squared is equal to r squared. Good. So now this square root of 27 can be simplified further using sword. You can simplify it to 3 root 3. Now how do we simplify it to 3 root 3? You have the square root of 27 is equal to the square root of 9 times 3, which is equal to the square root of 9 times the square root of 3, which is equal to 3 root 3. So instead of square root of 27 here, you can replace it with 3 root 3. Now, this is our general form of putting it. Before we go on, I would like to check if that the recording, the audio and everything is still working fine. Testing. Test. Okay. Okay, we are good to go. Audio is working, so let's continue. Now, this is not the end of it. This is the standard form x minus 1 all squared plus y plus 1 over 2 all squared is equal to. Okay, in the option, the way they put it is they left it as 27. That is, instead of putting it as r squared, they just left it as 27. So you can also leave it as 27. If it is theory, I rather prefer you put it in in this form than just leave it as 27. But anyway goes, you still get your mark. Just like if it is in this form, whenever they ask you what is your radius, you can easily just pull out 3 with 3 and say that is your radius. If they ask you what is your center of the circle, you can easily get your center of the circle from these two terms here. So it's better to put it in this form than to put it with equal to 27. But remember this OBJ, so you have to follow your solution the way the questionnaire gave it to you. So you have equal to 27. So that's good and fine. Now, how do we find our center from this? To get your center, remember I told you that the actual general form is with x minus h abcd. I don't like using h here. X minus g. In fact, actually, the way me I learned it is x minus g with f. That is x minus g all squared plus y minus f all squared. But the way I've seen most other teachers teach their students is with actually x minus d all squared plus y minus h all squared, where d will now be the distance and h will now be the height. So different lecturers, different teachers have different ways of showing their own general form. So I'm just going to use it the way I was taught, but the way me I actually prefer, I like think using G and F because of that's the way me I was taught. So it's easier for me to understand using G and F. But whichever way you are taught, remember they are just coefficients. They can change. Some other people can use A and B. It's their choice. Coefficients can change. So me, I'm going to use G and F. So you have x minus g. So you have x minus g all squared plus y minus h all squared is equal to r squared. Now the center of this circle is going to be g comma h. Now why is it g comma h? The reason why it is g comma h is because of how the general form was in the first place. Now how was this general form gotten? Let me do that over here. If you have your Cartesian plane like this and you have a circle over here, this is your center. The center here is g comma h, and this is a point in your circle x comma y. You can form a right angle triangle like this, where here is x, no, is y, where here is y minus h, and the horizontal is going to be x minus g, and your length here is going to be the radius of the circle. So you have x minus g all squared plus y minus h all squared. Okay, may I use h, y minus h. I was actually taught using f, y minus f. But I told you whichever way you are taught is good and fine. So y minus h all squared is equal to r squared. That is where you got that g and h from. So here, if you have x minus g, the g itself would be your x coordinate for your center. If you have y minus h, the h itself will be your y coordinate for your center. So this is how the general formula was gotten, and we are going to use that to get our center of our expression or our circle. Okay. If you look at it over here, you have x minus 1 already. So we already know that our center is going to have 1. But if you look at y has plus. Now, why does y have plus? Y is not negative. Well, you can let's say brute force that negative inside here. So if you have y plus half, this y plus half is also equal to y minus half. No. Let's do it this way. You have y minus half minus half. Yes. This is a better way of doing it. You have y plus half is equal to y minus half, because minus times minus gives you a plus. So you have y plus half is equal to y minus half. So this one would now be your y coordinate for the center. So you have 1 comma minus 1 over 2. So you have y plus half, that means your center is going to be minus 1 over 2. If you have x minus 1, it's going to be 1. If you have y plus, it's going to be negative. So it's basically just multiplying this by minus 1, multiplying this by minus 1. Now, what does this mean for us? Oh no, before I say what does this mean for us, let me find our radius, because they ask us to find the general form, which is this. They ask us to find our center, which is this. Now let's find our radius. For our radius is going to equal to this term here. Some of you guys have saw this thing before because of these questions look familiar that I have attempted. You know, I'll just continue because I can't remember where I saw them, but I believe this solution is familiar to my head. Okay. Now, how do you find the radius? As I say, this term here is equal to your r squared term. So your radius is basically just this term that's inside this bracket. So our radius is going to equal to 3 into 3 units. I don't know if the option is put the option did not put units, but I said if it's theory, just put 3 units. Okay, so these are the four answers. X minus 1 whole squared plus y plus half whole squared is equal to 27. Our center is 1 comma minus 1 over 2, and our radius is equal to 3 with 3 units. Now, if it is theory, sometimes your lecturers can ask you to graph it, like show a graphical representation of what this means. Now, what does this mean? It means that you have your center point at 1 comma minus half. So this is when x is 1 and when y is minus 1 over 2. This is your center. It also has a radius of 3 root 3. So let's just say the radius of this is 3 root 3 here, and you have a circle that looks like this. I'm not an artist, but you have something that looks like this. This is your center, 1 comma minus 1 over 2, and your radius here is equal to 3 root 3. So this is basically what it means. X minus 1 whole squared plus y plus 1 over 2 whole squared is equal to 7. Graphs a circle that has a center 1 comma minus 1 over 2 with a radius of 3 root 3 units. With no further ado, let's pick our option. Option A has the correct, no, option A is wrong, because if you look at this term, you have y plus 1 whole squared, which is wrong. It's supposed to be y plus half whole squared. Let's go to option B. Option B is wrong because of the center. The center has 1 comma half. It's supposed to be 1 comma minus 1 over 2. So option B is wrong. Option C, it is the term that is attached to x that is wrong, because option C has x minus 2 whole squared. So option C is wrong. Option D is correct, but option D failed in this radius side. The radius for option D is root 3 instead of 27. So the correct answer to this question is E, none of the above, because none of the given options are correct. So the correct question 1, the correct option is option E, none of the above.
So this will be x, x. This x minus 1. What are the critical points?
Okay. Question 1, the correct answer is E. Let's go to question 2 now. Question 2 says, which of the following statements is true? Okay, let me just give a brief explanation to this conic, these general forms of conic circles, of conic segments, conic sections. Let me give a general explanation for these conic sections. Okay. So the general form of these conic sections, you have ax squared plus bxy squared plus cx plus dy plus e. Most of the times there would be an e xy term plus an f term is equal to 0. So now this is general form for all conic sections. But now what do they imply? Okay, When A and B are the same
Please take time.
and they are non-zero, it will give you circle. Then A is equal to B and they are not equal to zero, it will give you a circle. It will give you a circle because I don't really know how I will explain the because, but if you look at the general form of a circle, you have x squared plus y squared plus an x term plus a y term plus an f term. So you have A is equal to B and they are both not equal to zero, and E should also equal to zero. E should equal to zero because there should not be an xy term. Okay. For a parabola, or let's go to an ellipse. For an ellipse have a general form of x squared divided by A plus y squared divided by B is equal to zero. So now, what do we get from here? I think it's x squared divided by, x squared divided by A squared plus y squared divided by B squared is equal to zero. Now, how do we get the general form from here? If we multiply all through by A squared, B squared, you're going to have x squared plus, no, you're going to have b squared x squared plus um, a squared y squared is equal to zero. Now this x mustn't always be x. It can be x minus 1, x plus 2, x plus whatever, if the center is not 0, 0. So because of this, you are going to have an x squared term, you're also going to have an x term, and you're going to have a constant term. The same thing happens for y squared. You're going to have an x squared term, you're going to have a y squared term, you're going to have a y term, and you're going to have a constant term. So if you look at it, there's going to be an x squared term, there's going to be a y squared term, there's going to be an x term, there's going to be a y term, and there's going to be a constant term. But the only difference here is if you look at the coefficient of x squared, you're having b squared. If you look at the coefficient of a squared, of y squared, you're having a squared. So that means a and b are not going to equal to zero.
So this minus them.
So for an ellipse, a is not equal to b. If but a can be greater than b and b can be greater than a, but it should not be equal to each other. If they're equal to each other, there's going to give a circle. The second thing is e should equal to zero. In fact, basically, I think e is equal to zero in all of them. So let's just cancel out this ex squared, exy term, and turn it to be constant. E will be equal to zero for all of them. So because of that, you can just remove this here because e now is a constant and f has gone. E now is a constant. So you can also remove this. A should not equal to b, and a and b should be greater than zero. Now, how do I know that a and b are both greater than zero? It's because of in that place we saw a squared is the coefficient of b squared is the coefficient of x squared, and from that you know that anything squared is going to give you a whole number, a natural number. It's going to give you a positive number. Basically, it's going to give you a positive integer, and that is squared going to give you a positive integer. So that a and b are both going to be greater than zero. Okay, the second thing, the next one is going to be a hyperbola. No, parabola. Parabola. Okay, for parabola, the general form of it is y is equal to 4py is equal to x squared. We have 4py is equal to x squared. Now, this x I said mustn't always be x. It can be x minus 1 or x minus a, depending on the point, the center of the parabola. So if you square this, you're going to have an x squared term, you're going to have an x term, and you're going to have a constant term. The same thing happens for y. So y can be y minus b. Y minus b. So you're going to have a y term, and you're also going to have a constant term. So if you look at it, there's an x squared term, there's an x term, there's a constant term, and there's a y term. So for parabola, there are two cases. Case 1, a is equal to 0, b can be equal to anything, c can be equal to anything, d can be equal to anything, and e is equal to anything. A is equal to 0 or b is equal to 0. So if A is equal to 0 or B is equal to 0, it's going to give a parabola. The next one is going to be a hyperbola. For hyperbola, you are going to have x squared divided by a squared minus y squared divided by b squared. So now let's divide all through by 2. If you divide, sorry, is equal to 0. Now let's multiply all through by a squared b squared. You multiply all through by a squared b squared, you're going to have b squared s squared minus a squared y squared is equal to 0. Now if you look at it, as I said, the x mustn't always be x. X can be x minus a depending on where the center of the point is. So if you square that, you're going to have an x squared term, you're going to have an x term, and you're going to have a constant term. The same thing for y, you're going to have a y squared term, you're going to have a y term, and you're going to have a constant term is equal to 0. So there's an x squared term, there is a y squared term, there's an x term, there's a y term, and there's a constant. But there's a catch. If you look at x squared here is have a positive coefficient because of b squared is always positive. But if you look at y squared has a negative coefficient because a squared is always positive and minus or negative a squared would always be negative. So for hyperbola, one of them should be negative. For hyperbola, there are also two cases.
The first derivative.
A is greater than 0 and
The first
b
derivative was
is less than 0,
with the velocity. The
or
second derivative is acceleration.
a is less than 0 and b is greater than 0. That is, one of them should be positive, the other one should be negative. So these are basically the four of them. I don't know if there's more. Let me just give it a little bit search. Okay, sections. Okay. For circle, A and B are equal to each other and they are both not equal to 0. For ellipse, okay, what they put here is going to be a little bit confusing, but then here they have the b squared term minus 4ac is going to be less than 0. What it means is that A and B are not going to be equal to each other and B is not equal to 0. Okay, that means A and B are not equal to each other and there's going to be an xy term for ellipse. A and B are not equal to each other, there's going to be an xy term. For parabola, you have b squared is equal to 4ac. They will not put small dimension, but just forget all these ones. Just know that for parabola, A is not equal to B or B is equal to, sorry, A equal to 0 or B is equal to 0. That is, one of these terms will not be here. One of these terms will not be here. For parabola, A is greater than, A is going to be positive and B is going to be negative. Or A is going to be negative and B is going to be positive. One of them will be positive, the other one will be negative. That's how you differentiate the four of them.
Hello, sir. I want to speak in. Yes,
That's how you
sorry, I
differentiate
want
the
to
four of
aim
them.
at the
So for this
example.
question, the closest answer is going to be B, because for B you have A is not equal to 0 and B is not equal to 0. But if you look at it, A is not equal to 0, B is not equal to 0 can
Yes.
also be a term for an ellipse. A is not going to equal to 0, B is not going to equal to 0, but
he's going
they
to
would not be equal to each other.
Then he will
That
make
is,
two
if A
dimensions.
is greater than B or if B is equal to greater than A, then you are going to have an ellipse. But and also if A is negative and B is positive, we are going to have a parabola. So you can see, just because they are both not equal to 0 does not mean it's going to define only a circle. If A and B are both not equal to 0, it can also define an ellipse, it can also define a hyperbola. That is, if they're going to not equal to 0. So the only thing that this option B gave us is it did not define a parabola. It defined every other thing except for a parabola. So this answer, this question is actually not going to have an answer. And also, what the lecturer did is he did not give the answer to the none of the above, since the options were not complete. He since it did not have the a is equal to b term, or in case they didn't want to have an a equals to b term, they can just change this to a. They can change this to a. If you have ax squared plus ay squared, then there's no need for you to specify that a is equal to b. You can just say a is not equal to 0 and to still define a circle. So this question actually was given as a bonus. So there's no answer for this question. So let's go to question 3. Question 3 says, which of the following statement is true? Now let's explain what a parabola is. The parabola is the set of all points that the distance from the point to a fixed point is equal to the distance from that point to a line, if it's a straight line, a directrix line. Now, if you have this as your x-axis and here as your y-axis, and this is our fixed point 0, p, then this will be our directrix line. Y is equal to minus p. Okay. So we're looking for all the points
for any exam right. So I said for any
the distance from here. That means a is equal to b. The distance here will be the same as the distance here. Okay. Now let's see if we can use this to solve this question. The general form of this is going to be 4py is equal to x squared. We have 4py is equal to x squared. Equal to x squared, we are going to have in this form. It's going to curve up. The fixed point is going to be at 0, p. Okay? And if 4px is equal to y squared, then it's going to be like this. It's going to curve towards the right. If it is negative, if p is negative, then it's going to curve towards the left. If p is negative for this one, it's going to curve downward. So let's see if we can answer this. Option A. The equation of the parabola is y squared is equal to 4px. Y squared is equal to 4px. Is the equation of parabola whose vertex is at the origin. The vector is at the origin, but the focus is at 0, p. No, 0, p is for this formula. For this one, the focus for these horizontal ones are going to be at p, 0. The reason why 0, p is because of is at the y-axis, and at the y-axis x is equal to 0. So we have 0, a point p. But if it's at the horizontal axis, you are going to have y is equal to 0, and you are at the point x, p. Okay, so option A is wrong. Option B now, the equation of the hyperbola is x squared is equal to 4py. So we have this one. This one is the equation of the parabola whose vector is at the origin, and the focus is at p, 0. No, p, 0 is for the horizontal one. So option B is wrong. For option C, the equation of the parabola x squared is equal to 4py is the equation of the parabola whose vector is at the origin. We have x squared is equal to 4py, that is this one. The vector is at the origin. Whose vector is at the origin, and the focus is at 0, p. And the axis is horizontal. No, the axis is not horizontal. The axis is vertical. Like the y-axis. Everything is correct in that option C, but the axis is vertical, it's not horizontal. So option C is wrong. Option D, the equation of a parabola x squared is equal to 4py, that is this one again, is the equation of a parabola whose vertex is at the origin, and focus is at 0, p. The focus is at 0, p, and the axis is vertical. So option D is correct. Okay, I'll go over it again. The equation of a parabola is x squared is equal to 4py. Remember, I can say when it's x squared, it's going to curve up or down. If it is x squared, it's going to curve up or down. If p is positive, it's going to curve up. If p is negative, it's going to curve down. If it is y squared, it's going to curve left or right. If p is positive, it's going to curve right. If p is negative, it's going to curve left. So the equation of a parabola x squared is equal to 4py is the equation of a parabola whose vertex is at the origin, because there's no x plus a squared term or y plus b term. It's going to be at the origin because a and b are both equal to 0. That means your center is going to be 0, 0. So it's going to be at the origin. And the focus is at 0, p. That is what the focus is. If it is horizontal, it's going to be p, 0. But the vertical is going to be 0, p. And the axis is vertical. The axis is vertical because we're using the y-axis, and the y-axis is the vertical axis. So we have the correct answer is going to be option D. Question 3, we have option D. Question 4 now is not solvable, but let me write it down. Okay. Question 4 says, given the equation of a parabola, the equation of the parabola is x minus 1 over 2 all squared is equal to 3 brackets x plus 1. Now, this here is just going to give you a quadratic equation, and you're just going to end up having two lines. That is, you end up having, let us say you end up having x plus a all squared is equal to a constant c. So you end up having something like this after you're through solving, and you end up getting x is going to equal to negative a plus minus square root of c. So you end up just having two lines, two vertical lines. X is equal to negative a plus root c, and x is equal to negative a minus root c. Now, what do I mean? What I mean is that if you are going to completely define a parabola, you're supposed to have an x term and you're supposed to have a y term. The reason why you hear people say ax squared plus bx plus c will give you a parabola is because it's not just ax squared plus bx plus c is equal to 0. It is ax squared plus bx plus c is equal to y. That is why it's giving you a parabola. But if you're just having x squared plus bx plus c is equal to 0, they are just solving a quadratic equation that will give you two solutions, which is, let's say you draw the parabola of ax squared plus bx plus c is equal to y. And the parabola that you get is like this. When you now give me x squared plus bx plus c is equal to 0, what I'm simply going to tell you is these 2 points where this is our parabola across the x-axis, that is these 2 points here. What I'm going to tell you is I'm going to just draw a vertical line like this, and these 2 points will be our solution. X is equal to whatever this point is, a1, and x is equal to a2. That is why I said this question is not solvable. It does not define a parabola. Instead, it defines two straight lines. But let's just solve it as if it's correct. Let's solve it as if it's correct before I now make the correction that will make it, something that is solvable. Let's just solve it as if it was correct. If it was correct, then we're going to have the letters are going to be x squared minus 1 over 2x minus 1 over 2x plus 1 over 4 is equal to 3x plus 3. You're going to have x squared minus x plus 1 over 4 is equal to 3x plus 3. Move them to the left hand side. You're going to have x squared minus 4x minus, this here will be 12 over 4 That will be minus 11 over 4 is equal to 0. Then you can now solve this using quadratic equation and get your value for the two values of x equals to a1 and x equals to a2. Now you can see the reason why I said this is not solvable. The people that picked answer in this question, they assumed that is probably maybe they see this question in past question before and they assumed that this x here was y or this x here was y. So that's what we're going to do now. We're going to now this question actually is a bonus, so there's no answer for this question. But let's assume that one of these x's were y, so we'll be able to solve it. But you can see that if we're just giving this question like this, it's not going to be solvable because you have two x's. By the time you move everything to the right hand side, you're going to have a quadratic equation which just gives you two values for your x, and that's just simply just two straight lines in your graph. But let's just solve this, assuming that maybe this is y. Let's assume that this is y. So you have x minus half all squared is equal to 3 times y plus 1. Now, if I'm assuming that this is y, remember our general form is going to be x minus a, b, c, d, f, g, x minus g all squared is equal to 4p bracket y minus a, b, c, d, f, g, h. Okay, we have x minus g all squared is equal to 4p bracket open y minus h. So our center is going to equal to g comma h. So in this case now, our g is going to equal to half, or you can say minus g is equal to minus half. Divide both sides by minus 1, you have g is equal to a half. So our center for this particular case is going to equal to 1 over 2, comma, for our y, we are going to have 1 is equal to negative h. Divide both sides by minus 1, you have h is equal to minus 1. So you are going to have 1 over 2, comma, minus 1. So this is our center. The second thing we can ask you to find is your P. That is the point, your focus point. And to get your focus point, you have to equate 4P to 3. 4P is equal to this, sir.
Good day, sir. Please, where is computer room or mathematics?
Computer room or computer lab?
Computer lab or something?
Downstairs. Down.
They have one exam there now.
Downstairs.
Okay, sir.
When you go to downstairs, right? Just take the hallway
Okay.
to the other end,
Okay.
then move
To the right or left?
Right.
Right.
Straight down. Sorry.
So in the Bible side by 4, you're going to have P is equal to 3 over 4. Now, if P is equal to 3 over 4, if you check it, you have x squared. This is going to be, remember, I said, I told the last time that the general form for a circle was x squared plus y squared is equal to r squared. And I was like, it must not always be x, it can be x minus a, where a is going to be like our x axis for the center. Okay. So in this case too, we have the condensed form is going to be x squared is equal to 4py. Okay. Now if it's x squared, remember I said it's going to be vertical. If it's x squared, it's going to be vertical. If it was y squared, it's going to be horizontal and to curve towards the right or the left. But in this case, it's x squared, so it's going to be vertical. It curves towards the top or the bottom. And if you check our value for p, our value for p is greater than 0. So our value for p is equal to positive. So it's going to curve up and not down. If our value for p was negative, it's going to curve down. But so our value for p is positive, it's going to curve up. So we have 0, p. The reason why it is 0, p is because of it's on the y-axis. And on the y-axis, x is going to equal to 0. So you have 0, p. Now our value for p is going to equal to 3 over 4. 3 over 4. Okay. And the number has us find our focus point. It has us find the axis of symmetry. Okay, the axis of symmetry is going to be different from this. For the axis of symmetry, we are going to have x minus 1 over 2 and y plus 1. The axis of symmetry is going to be x is equal to whatever the x term is. So in this case, our x is going to be a half. So our axis of symmetry is going to be x is equal to 1 over 2. So this is not center, this vertex. Is center only for circle. for circle is going to be center. Center is going to be center for circle, parabola. No, circle and ellipse. We're going to be vertex for things like parabola, hyperbola is going to be vertex. So okay, in this case, our line of symmetry is going to be that line that cuts our parabola into half. And since this our parabola is a vertical one, that is, it curves upward, the line that passes is going to be x is equal to whatever the x term in the vertex is. And that x term is going to be x is equal to a half. So our line of symmetry is going to be x equals to half, and our vector is going to be a half comma minus 1. And from the options, that is going to be option C. Option C. That is if in the question you saw y here, but remember in the question you saw x, so that question is not solvable. But in the question if you saw y here, then your vector is going to be a half comma minus 1, and the axis of symmetry is going to be x is equal to a half. Now the second case, what if we didn't see y in the right hand side? What if we saw y in the left hand side? So let's erase this y from here and pull back our x, and let's clean this x here and pull back and pull y. So what if we saw y in the left hand side and we saw x in the right hand side? Now how do we solve this? In this case now we have y is the one that has the squared, so it's going to curve towards the right because our p is positive, so it's going to curve towards our right. So the first thing to find is our vertex. Our vertex is gotten from these two terms, this term and this term. You make it negative. For this x is going to be negative 1, and for y is going to be positive half. There's no need to go through everything. I've already solved it before. I'm just changing the y's and the x. So there's no need for me to the same explanation for the previous one, the same explanation for this one. Just that instead of x, they are going to put y's. So now for our line of symmetry, since it cuts the since it's turning in curves towards the right, our line of symmetry is going to be parallel to our x-axis. Since it's parallel to our x-axis, that means we're going to have y is equal to whatever the y term is here. So that's y is equal to a half. So our line of symmetry, LOS, is going to be equal to y, is going to be y is equal to a half. And in this case, it's not inside the option. So it's possible that the question that they wanted to ask was x minus half all squared is equal to 3 bracket open y plus 1. But I said it's not basically what they want to ask that you will go with is OBJ. So and there's none of the above inside the option. So whenever it's advisable to just go with none of the above than to you assume your own solution, and then you now end up having a solution inside the option. But then you set your own questions by yourself. So in case sales kind of question and they make all these minor mistakes by maybe they change something that makes it not solvable. Like in the test one, I remember they said a vector A was a unit vector. Then actually ended up giving that a magnitude. In those kind of cases that you're having all those contradiction, it is advisable not to assume anyone. Don't assume that okay, maybe since they put a unit vector first, then that means what they wanted to solve is you assume is putting that as a unit vector. Or you come and say since they put the magnitude second, that what they wanted to actually say, the main one they wanted to say was using the magnitude. No, don't assume your own solution. Follow what they gave you. And what they gave you was x and x, which is not solvable. So what you're supposed to put there is none of the above. But by the grace of the lecturer, they give that question as a bonus, both for the people that pick none of the above and for the people that did pass question and assume their own solution. So it was none of the above. I mean, it was bonus that they gave for that question. Let's go to question 5 now. Okay, question 5. Find the standard form and determine the intercept of the ellipse 3x squared plus y squared is equal to 5. So you have 3x squared plus y squared is equal to 5. The general form is going to be x squared divided by a plus a squared divided by a squared plus y squared divided by b squared is equal to 0. But no, it's not equal to 0, it's equal to 1. I made a mistake in the other past some previous those past questions I've been solving. I think question 1, 2, and 3. I mean it's not equal to 0, it's equal to 1. It's equal to 1, not equal to 0. Okay, for parabola, is it parabola? Ellipse, sorry, for ellipse. You are going to put it in this form. Is equal to 1, not equal to 0, equal to 1. Okay, you are going to put it inside this form. Now, put inside this form, the first thing we need to make sure that the right hand side is equal to 1. So to make sure that the right hand side is equal to 1, you have to divide both sides by 5. If you divide both sides by 5, you are going to have 3 over 5x squared plus 1 over 5y squared is equal to 1. The next thing, you need to turn all this correction of x squares to divisions. That's basically, if you have ax squared, this is the same thing as x squared divided by 1 over a. Or if you have 1 over a x squared, this is equal to x squared divided by a. So let's turn all this to divisions. So instead of 3 over 5x squared, we're going to write this as x squared divided by 5 over 3 plus y squared divided by 5 is equal to 1. So use that water.
Water, thank you.
Oh. Okay. Okay, this is our standard form. X squared divided by 5 over 3 plus y squared divided by 5 is equal to 1. For our intercept, how do you define an intercept? Intercept is where it cuts the y-axis and where it cuts the x-axis. So where does it cut the x-axis? To cut the x-axis, y must equal to 0. So if y is equal to 0, this is our x-axis. For it to cut the x-axis, y should equal to 0. If y is equal to 0, you have x squared divided by 5 over 3 plus 0 divided by 5 is equal to 1. 0 divided by 5 is just plus 0. And plus 0 is just nothing. So just have the x squared divided by 5 over 3 is equal to 1. This implies that x squared is equal to 5 over 3. Therefore, x is equal to the square root of 5 over 3. So for the x-axis, you have x is equal to plus minus the square root of 5 over 3. You have x is equal to plus minus the square root of 5 over 3. But if you check the options, there's no square root of 5 over 3 there. So the question is, what did they do? They rationalized. Since you have square root of 5 over 3, you can multiply the numerator and the denominator by root 3. So that you have root 5 over root 3 times root 3 over root 3. Root 3 times root 3 is just 3. Root 5 times root 3 is root 15. So you have plus minus the square root of 15 over 3. So you have x is equal to plus minus square root of 15 all divided by 3. For the y-axis, what defines the y-axis? X is equal to 0. When x is equal to 0, you have 0 divided by 5 over 3 plus y squared divided by 5 is equal to 1. 0 divided by 5 over 3 is just 0, and 0 is basically nothing. So you have y squared is equal to 5. That means y is equal to plus minus the square root of 5. So for our y-axis, we are having y is equal to plus minus the square root of 5. Now, how do you put this our solution in theory form? Like, how do you represent what you have just solved now? To represent what you just solved now, remember, an intercept is a point. That's the y, but the y-intercept is basically a point where two things intersect. So since this is the x-axis and y is equal to 0, then our point here is going to be plus minus the square root of 15 divided by 3, 0. That is y is equal to 0. And for our y-axis, x is equal to, so you have 0, plus minus root 5. Now, what does this mean? Let me draw a parabola. No, an ellipse. Let me draw an ellipse for us here. So you have an ellipse here, and it looks like this. This is going to be our x-axis, where where the graph cuts the x-axis. The first point here, negative root 15 over 3. Negative root 15 over 3. And here is going to be our second x-axis point, where the graph cuts the x-axis again, and this is going to be plus root 15 over 3. This is going to be our first y-axis where the graph cuts the y-axis, and they are going to have plus root 5. And this is going to be our second y-axis where the graph cuts the y-axis again, and this is going to be negative root 5. So these are basically the 4 points where this our ellipse cuts our axis, intersect with our axes. So these are how you present these 4 points: plus minus 15 over 3, comma 0, and 0, comma 15 over 3, and 0, comma plus minus root 15. Sorry, and 0, comma plus minus root 5. So which option is the correct option? Which option represents it completely? Option A, x squared divided by 5 over 3 plus y squared divided by 5 is equal to 1. That is correct. And the intercept is plus minus root 15 over 3, comma 0, and 0, comma root 15 over 3. Sorry, and 0, comma plus minus root 5. So our answer is going to be option A for question 5. Option A. Okay. Now, why is B, C, and D wrong? Option B uses negative. When it is negative, it defines a hyperbola, not an ellipse. Option C. Option C is correct, but for option C, if you look at the x-intercept, the only one they put there was root 15 over 3, comma 0. There was no negative root 15 over 3. That is why option C is wrong. Option D, there is, for the y-intercept, there's no negative root 5. So that's why option D was wrong. So option C and D are both wrong. But option A completely defines our standard form and our intercept for the ellipse. Okay, let's go to question 6 now. Question 6 is for a hyperbola. Question 6 is for a hyperbola. You have 4y squared minus x squared is equal to 5. The same thing happens. We want to make sure that our right hand side is equal to 0. So you have 4 over 5y squared minus 1 over 5x squared is equal to 1. These are step 1. Step 2, you need to make sure that all these coefficients goes down as a denominator. So you have y squared divided by 5 over 4 minus x squared divided by 5 is equal to 1. Okay. Okay, this is our standard form. The next thing to find is our intercept. For intercept, for a hyperbola, sorry, the hyperbola is graphed like this. Since y squared is the one that has the positive coefficient, then we are going to have something like this. It curves up and curves down. But if x had the positive coefficient, there's going to curve towards the left and the right. Okay. So in this case, we have that y squared, since y squared has a positive coefficient, is going to curve up and down. So you are going to, and that is the y-axis, and the y-axis x is equal to 0. So you have just the x-axis, sorry, the y-axis case. For the y-axis case, that is when x equals 0, you have y squared over 5 over 4 minus 0 over 5 is equal to 1. 0 over 5 is just going to be 0, and minus 0 is just going to be nothing. So you have y squared is over 5 over 4 is equal to 1. This implies that y squared is equal to 5 over 4. If you square both sides, this implies that y is equal to square root of 5 over 4. So plus minus square root of 5 over 4, which is equal to plus minus square root of 5 divided by 2. Now, remember, this is not the way you put it inside your theory. You put it as a point. The y-intercept is going to be 0, that's when x is equal to 0, and y is equal to plus minus root 5 over 2. Now, why is there only y-axis case? Why isn't there an x-axis case? The reason why there's no x-axis case is, let us assume that there was an x-axis case. That means y squared is equal to 0. So if y is that means y is equal to 0 and y is equal to 0, that means y square is equal to 0 and y square is equal to 0, that means y square divided by 5 over 4 is going to just equal to 0. So everything is going to equal to 0 for the left hand side. For this part, we're all going to equal to 0. So all you be left with is minus x squared divided by 5 is equal to 1. If you multiply both sides by minus 5, you're going to have x squared is equal to minus 5. If you square both sides, you're going to have x is equal to plus minus root 5I. You can see that this gives us an imaginary term. So in the real axis, the real x and y plane, there's not going to be an x-intercept. That is usually why we only deal with the case of y-intercept. And in case you still don't understand this imaginary solution that we just assumed here, you can also graph it. If you graph it, when y is greater than when y has the positive coefficient, it's going to be graphed upward and downward. You can see that it never crosses the x-axis from both ends. That's why there's no x-intercept. There's only y-intercept for this particular case. But in case you have x squared divided by 5 over 4 minus y squared divided by 5 is equal to 1, then the intercept here is going to be plus minus root 5 over 2, comma 0. But since this was not what was given, our answer is going to be y squared divided by 5 over 4 minus x squared divided by 5 is equal to 1, and our intercept is 0, comma plus minus root 5 over 2, which is option A. Now, the reason why option B is wrong is because they said 5 over 2 is corresponding to 5 over 4 here, not 5 over 2. Option C is wrong because they use plus, and option D is wrong because they don't use plus minus in their with 5 over 2. Remember, for a parabola, curves up and curves down, you have your first point where it cuts is going to be plus with 5 over 2, and the second point where it cuts is going to be minus with 5 over 2. So for question 6, we have A. Let's move on to question 7. Question 7 now gives us another hyperbola, but in this time they made x have the positive coefficient. So you have 2x squared minus 5y squared is equal to 6. We should find the same thing. I'm not going to explain much, but I've already solved the whole thing previously in question 6 in depth. So divide both sides by 6, you are going to have 1 over 3x squared here, minus 5 over 6y squared is equal to 1. So that will be x squared divided by 3 minus y squared divided by 6 over 5 is equal to 1. Okay, this is only our general form. We finish one part. The second part is to find intercept. Remember, for since x has the positive coefficient, then the intercept is going to be when y is equal to 0. When y is equal to 0, this term here cancels out. So that will just be x squared over 3 is equal to 1. That means x squared is equal to 3. That means x is equal to plus minus the square root of 3. So our intercept is going to be, this implies that our intercept is going to be plus minus root 3, comma 0. This is option x squared over 3 minus y squared over, no. A is wrong because they say 6 instead of 6 over 5. B is wrong because they say 6 instead of 6 over 5. C is correct. C is correct. X squared over 3 minus y squared over 6 over 5 is equal to 1, and intercept is plus minus root 3 over 3, comma 0. Option D is wrong because they use 6. In fact, option D is wrong because they also use plus instead of only 6. Okay, my daddy just joined the live. He said, boy, you've time for live stream. How about your ongoing exam? I finished an exam today. That was ENT. Then the next exam is on Monday, physics. So I'm not really reading for physics day against the people that want to use it and practice on that day. So that's the end of question 7. Question 7, the correct answer is option C. And finally, we moved on to this, which I believe, let me just quickly send the link again to everybody because I'm not sure this is the part that plenty people are worried about. Okay, already 1 hour into the live stream, we can there's still time to solve the remaining. Okay. Let me quickly send the link to everybody again, telling them that we've reached kinematics part. So good evening, everyone. This is phase 1 to 3 worksheet. Okay. Network seems to be breaking. I think is it from my end? Let me check my feedback on YouTube.
Plus minus square root of 5 over 4, which is equal to plus minus square root of 5 divided by 2. Now, remember, this not the way you put inside your theory. Put it as a point. Y intercept is going to be 0, then the x equal to 0, and y is equal to plus minus 5 over 2. Now, why is there only y at this case? Why isn't there an x at this case? The reason why there's no x at this case is
Okay, let's begin. Let's continue. Question 8. Question 8 says the curve traced by a moving particle is called the curve traced by a moving particle is called the trajectory of um, that particle. Basically, you must not. I know when you hear trajectory, the person you imagine is a projectile that is thrown. But this also still is still the curve of that moving particle, which in this case is going to be the projectile that is moving. But the projectile is not only just the only object that's each part of x will still be its trajectory. Moves along curve, because x is a straight line, but just call it a curve. If you have then this will be its trajectory. So now for question 8, we have option C is the correct answer. Question 8, we have option C. Now option a vector is basically, I don't really know if what I'll use an entity or it's just basically something that has a magnitude and direction. Coordinate is I don't really know the words. I don't know how to explain this with words, but coordinate system is like your x and y system. You can't confuse them. Coordinate system with your x and y axis or something. Gradient is, oh god, let's see. I don't know how to explain it, but gradient is gradients. Yeah, so just I don't know how to explain this thing, but triangle of shadow is the curve that is traced by a moving particle. The relationship between your curvature and the radius of curvature is k is equal to 1 over p. The relationship between your curvature and your radius of curvature is k equals. Now, for this, I still don't know how I will explain this because I'm not really the mathematician I went to, but there's way I understand how this is. If you have a circle, x square plus y square is equal to r square, and the radius of this circle is 1, r is equal to 1. And you have another circle, x square equals y square, x square plus y square is equal to r square, and your radius for this circle is keep going. Let me take care of some stuff later. Bye. Network. Okay, bye. Yeah. So if you have another circle and this circle has a radius of 100, you can see that the at this point it begins to look like a straight line. For here, it's curving more, but at this point, if I let us say I have a unit box, a small box here that captures this particular moment, it looks curved, more curved than from here that looks like a straight line. That is the reason why on Earth we already know that the Earth is a globe. But if you are looking just for a small point, a small part of it, it will look like a straight line. So if you have a smaller circle, this smaller circle here that have radius of 1, and you capture this small box here, maybe a unit box here, it looks like a curve. But if you have a bigger circle with radius equal to 100 and you use that same size of box to capture a part of that circle, it will look more straighter and straighter and straighter and straighter. So that's basically it. The more the radius increases, the less it looks like a curve. The more the radius increases, the length look like a curve. That is the reason why the radius of curvature or the curvature is equal to 1 over the radius of curvature. That is, more the radius of the curvature increases, the less the curvature is. The more the radius of curvature, the less the curvature is. The less the radius of curvature, the more the curvature is. So that is basically how their relationship is. They are inversely related. K is inversely related to P, or K is equal to K is inversely to 1 over P. Okay, yeah. I believe that's been explained. Let's move on to question 10 to question 15. Question 10 to question 15. We have question 10. Find the radius component, blah 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 blah. Okay. Before we explain this, I want to explain what what is called that thing again? Radial component and transverse component is. So if we have this graph here, and we have this is our center point here, and we have a curve like this. Okay. How will I explain this? How will I explain this? How will I explain this? We have this curve with the component. Okay, you know what? Let me explain this another way. Let us say a vector follows this path like this. This is not our vector. This curve is not our vector. Instead, this is our vector here. This is our vector here. It follows this path. This, whatever this curve is, it follows this path. This our vector traces as the vector moves in time. It traces this curve like this. I want to analyze how this vector is moving. The first thing that a vector is defined by is its radius. That is basically what that radial component is. The radial component either increases it or reduces it. So this radial component is in the direction of our vector. This component either increases the vector or reduces the vector. If our radial component is positive, it's increasing the vector. If our radial component is negative, it's decreasing the vector. In this case, as you can see, as this vector is moving to this point, the radius decrease. So this our radial component will actually be negative. It's going to reduce our radius, our vector's radius. The next thing that a vector is defined by is its angle. And that's what that transverse component is for. The transverse component is basically just the turning component of vector. The radial component elongates or shrink it, while the transverse component turns our vector. So our transverse component, the reason why it's in this axis is because of we are turning from the positive x-axis to the positive y-axis, from positive y-axis to the negative x-axis, from negative axis to negative y-axis, from negative y-axis to the positive x-axis. It's turning anti-clockwise. So radial component is 90 degrees to our transverse component is 90 degrees to our radial component because it's the turning vector. It turns our vector. Okay, so now we have defined it. We have our radial part and our transverse part. Now, let's do some analysis here. If we want to find the unit vector for this our vector, is going to be the unit vector of our vector is going to be, let's say our vector is r, then the unit vector is going to equal to our vector r divided by the magnitude of our vector r. So this unit vector is going to equal to our vector r divided by the magnitude of our vector r. Okay. This angle here, let's just do this for now. I'm not going to need this now. If this angle here is theta, and this angle here is 90 degrees, then this angle that is here is going to be 90 minus theta. If this angle is 90 minus theta here, then this angle that is here is going to be 90 plus theta. Now, how do we get this? You can get this from one exterior angle of a triangle is going to equal the sum of the two opposite interior angles. So you basically don't need to know this part here. One exterior angle is going to equal the sum of the two opposite interior angles. Since here is 90 degrees and this angle here is theta, then this angle that will be here will be 90 plus theta degrees. So if our vector has an angle of theta, then its transverse vector would have an angle of 90 plus theta. Now, how do we define unit vectors? We define unit vectors as cos theta plus sine theta. The reason why this defines a unit vector is because of if you find the magnitude of cos theta plus sine theta is going to cos theta I plus sine theta j is going to give you a magnitude of 1. So cos theta I plus sine theta j defines a unit vector. Now, so our transverse vector, let's say t, is going to equal to cos 90 plus theta I plus sine 90 plus theta j. Cos 90 plus theta can be gotten from cos a plus b, which is equal to cos a cos b minus sine a sine b. In this case, a is equal to 90 and b is equal to theta. And if a is equal to 90, then cos 90 is going to equal to 0. So this is going to equal to minus sine theta. So cos 90 plus theta is going to equal to minus sine theta. And sine 90 plus theta can be gotten from sine a plus b. Sine a plus b is equal to sine a cos b plus sine b cos a. If a is equal to 90 degrees, then sine a is going to equal to 1. So this will be cos theta plus sine b, or that cos 90 is going to equal to 0. So this term will just cancel out. So you have cos theta. So sine 90 plus theta is going to equal to cos theta. So these are our transverse components, right? Is equal to minus sine theta I plus cos theta j. So our radial component is equal to cos theta I plus sine theta j, and our unit transverse vector. So our radial unit vector is equal to cos theta I plus sine theta j, and our transverse unit vector is equal to minus sine theta I plus cos theta j. Let me write that down. Let me write down up here. Radial component is going to equal to cos theta I plus sine theta j. Transverse component is equal to minus sine theta I plus cos theta j. Okay. Now that I've laid this basis, let's now apply where we need this transverse vector. Where we need transverse vector is when we're analyzing this our curve that the vector is moving. We want to find the velocity. The velocity of a vector, or the velocity vector, is equal to the derivative of our vector with time. The derivative of our vector with time. Now this derivative of this our vector here is equal to the magnitude of the vector times the unit vector. The magnitude, as I said, gives us our length of the vector. Why this our unit vector basically gives us our direction of it. Okay. So if you are defining our unit vector, remember the unit vector, it has a magnitude of 1 and it has a particular direction. So our magnitude defines the magnitude. Our magnitude of vector defines the magnitude, the length, while our unit vector defines its direction. Okay, so we have our vector is equal to its magnitude times its unit vector. So this is equal to the derivative of our magnitude, or let us call it r, times the unit vector with respect to time. So you are going to differentiate using product rule. For product rule, you keep one constant, differentiate the second one, dr dt, plus you keep the second one constant, differentiate the first one, dr dt. So now we have our magnitude times the derivative of our unit vector plus our unit vector times the derivative of our magnitude. I will just rearrange this by putting the radial component first. So we have this dr dt plus r the unit vector dt. This is already our radial component of velocity. Our radial component is going to be dr dt. But now let's find our transverse component. Transverse component can be gotten from here. If we differentiate our unit vector with respect to time, we will get whatever our transverse vector will be. If we differentiate our unit vector here, dr dt would equal to the derivative of cos theta I plus sine theta j with respect to time, which is equal to the derivative which is equal to the derivative of cos theta I with respect to time plus the derivative of sine, or this I can come out, plus the derivative of sine theta with respect to time j. If we differentiate cos theta with respect to time, this would be the same thing as differentiating cos t times the derivative. Let me just explain what they call that thing. Production or I find it hard to remember most of these things. Mr. Sir, when we are doing, let's say the x, the y, I want to do apply substitution. I will now do dx du. Sorry, but while finding the y dx, I will now do the y du times du dx.
That's true.
Chain rule. So now let's explain what chain rule is. Thank you, sir. For chain rule now, we are finding dy dx. This dy dx is equal to dy du times du dx. So if I want to differentiate y with respect to x, right? But y is not directly linked to x, y is directly linked to u. Then what you do is to differentiate y with respect to x, multiply it. Oh, okay. The recording is back. Okay, so in this case now, we want to differentiate cos theta with respect to t. But cos theta is not directly linked to t. So what we're going to do is to differentiate cos t with respect to t, then multiply it with the theta dt. So we're differentiating cos, we're differentiating cos theta with respect to theta, then we're going to multiply with the theta dt. We're differentiating cos theta with respect to theta, multiply with the theta dt. So this d theta will cancel out the theta here, and it doesn't have the same thing back here. Then I plus, we're differentiating sine theta with respect to theta, multiply it with d theta dt j. The j is gotten from here. So if you differentiate cos theta with respect to theta, you're going to have minus sine theta times d theta over dt times I. Plus, if you differentiate sine theta with respect to theta, you're going to have cos theta d theta dt j. Okay, let me rewrite all these things that I've done. Let me write everything up here. So this our derivative of our unit vector with respect to time is equal to minus sine theta d theta dt I plus cos theta d theta dt j. If you factor out the theta dt, you're going to have the theta dt bracket over minus sine theta I plus cos theta j. Minus sine theta I plus cos theta j equals to something very familiar. Is equal to our transverse unit vector. So you can substitute all this with our transverse unit vector. Okay, you know what? I'm going to exchange this t for s, because I don't want this t and this t to be confused with each other. So I'm going to exchange this with s. So s now represents our transverse unit vector. S represents our transverse unit vector and not t. So we have the dt, or the derivative of our unit vector with respect to time, is equal to the theta dt times our transverse vector. So the derivative of our unit vector with respect to time, we can exchange this with d theta dt times our transverse vector. Bring all this up. Okay, we have one person is viewing. So what we have done now, who is person that is viewing, okay, I pray you don't leave. Like and share and subscribe, that kind of thing. So now, this is our velocity. Velocity is equal to our radial unit vector times the derivative of our radius with respect to time plus our magnitude times the theta dt times our transverse unit vector. So our radial component of velocity, radial component of velocity is going to equal to dr dt. Our transverse component of velocity, this is basically our turning vector, the one that turns our actual vector, is going to equal to r d theta dt. I believe there's going to be a way of explaining this another way. Let me just see if I can give that. If you have this curve like this, and this is our vector moving through this curve, and we want to take a thin slice like this, we know that our r d theta is going to equal to this thin slice that we took here, dr. Our r d theta is going to equal to that derivative of radius. Our curvature, there's our change in, there's this change here between these two radius. Yeah, actually, it's still the same thing. Our change in r is going to equal to r d theta. And we divide, if you divide both sides by dt, the r dt, yes, if you divide both sides by dt, you're going to have r theta dt. So this is another way of getting the exact same thing, but it's going to be now transverse vector, our transverse direction. So you have the derivative of r respect to t is still going to give you r d theta dt times our transverse vector. So whichever way you still fit, though may I still prefer this calculation method than to use this graphical method, but whichever way you still fit, you still get the same expression. So our radial component of velocity is going to equal to the r dt, and our transverse component of velocity is going to equal to r d theta dt. I'll write that up here. Now let's find our acceleration, our radial component of acceleration and our transverse component of acceleration. To find the radial component of acceleration and our transverse component of acceleration, we have to differentiate our velocity again. So now let's do that. We have our velocity is equal to r dr dt plus s r d theta dt. So our acceleration is going to equal to our derivative of velocity vector with respect to time, which is equal to our derivative of r dr dt plus s r d theta dt with respect to time. Okay, this here is equal to the derivative of r dr dt with respect to time plus the derivative of r d theta dt s with respect to time. We're still going to apply chain rule again. Oh no, this is product rule, sorry. Keep r constant, then differentiate the r dt. If you differentiate the r dt, you are differentiating the second time. That's how the square r dt square. Plus, keep the r dt constant, differentiate differentiate the unit vector of r with respect to time. So that will be dr dt. Plus, the same thing that for production happens here again. Keep r d theta constant, differentiate our transverse vector with respect to time. Plus, keep our transverse vector constant, differentiate the theta dt with respect to time. So that will be r times our transverse vector. If you differentiate theta with respect to time twice, it will be the square theta dt square plus keep the theta dt times our transverse vector constant, differentiate r with respect to time. So that will be d theta dt times s dr dt. So now we can make some simplifications. This is our r vector here. Okay, so let us sum everything up. This is okay. We can do some simplification here. This is our derivative of our unit vector here with respect to time. We've already done this before. And when we did this, we got the theta dt. So what do we get? We get r theta. Yes, we got the theta dt. We got the theta dt times our transverse vector. Remember that part. We got the theta dt times our transverse vector. Okay. Now we have the derivative of our transverse vector here. Before we do that, let me write all this up here. So there'll be space for me to do the calculation. Okay. This will be r the square r dt square plus this here is the same as this here. So that will be plus 2 dr dt the theta dt transverse vector plus r the theta dt plus r the square theta dt square transverse vector, this one here, plus r the theta dt the transverse vector dt. So now we know everything. Now if you differentiate the transverse vector with respect to time, what do we get? Well, let's find out. If you differentiate the transverse vector with respect to time, that's basically just differentiating minus sine theta I plus cos theta g with respect to time, which is equal to the derivative of minus sine theta with respect to time times I plus the derivative of cos theta with respect to time times g. Okay. Now, since this is in terms of theta and this is in terms of t, they will apply chain rule. They will apply chain rule. I believe the recording is still going on. So we apply chain rule, and for chain rule, we have this is equal to the derivative of minus sine theta with respect to theta times the theta dt I plus the derivative of cos theta with respect to theta times the theta dt g. Don't think I need this. Okay. The derivative of minus sine theta will give you minus cos theta. This is equal to minus cos theta times the theta dt I plus, if you differentiate cos theta, you're going to have minus sine theta. Minus sine theta the theta dt times g. So the derivative of transverse vector is simply just, now let's start out at the theta dt. You have the theta dt here times minus cos theta minus I minus sine theta g. If you factor out minus 1 again, you are going to have minus the theta dt times plus cos theta I plus cosine theta g. And cos theta I plus sin theta g is equal to our radial unit vector. So the derivative of our transverse vector with respect to time is equal to minus the theta dt times our radial unit vector. So you can replace the derivative of our unit vector, the derivative of our transverse vector with respect to time here is minus the theta dt our unit vector minus, what did I write down here? I forgot it. Okay, I forgot what I wrote down there. Let me just quickly check the recording. I cleaned it before. My brain could store it in my head.
Let us assume that there was because
Okay. What was supposed to be written there is r d theta dt times the derivative of our transfer vector with respect to time. And we got that our transfer vector the derivative of our transfer vector with respect to time is going to equal to minus the theta dt times our radial unit vector. But remember, what was there was r d theta dt, so we're going to multiply by r d theta dt. Okay. So if you multiply, you're going to have minus r d theta dt all squared times our radial unit vector. You have minus r times d theta dt all squared times our radial unit vector. So our acceleration is equal to, for our radial component, is equal to d square r dt squared minus r d theta dt all squared, okay, plus our transverse vector 2 dr dt times d theta dt plus r d square theta over dt squared. Okay. So this here is our radial component of acceleration, and this is our transverse component of acceleration. So let me write down our full solution up here. For acceleration, our radial component is equal to d square r dt squared minus r d theta dt all squared. Our transverse vector of acceleration, our transverse component of acceleration is equal to 2 dr dt d theta dt plus r d square theta over this dt squared. Okay. 8 is C and 9. I think if we solve 9 was C. Okay, now we can solve question 10, 11, 12, 13, and no, 10, 11, 12, 13. Okay, now we can solve 10, 11, 12, 13 because these are the 4 things. Our radial component of velocity, transverse vector of velocity, radial component of acceleration, transverse vector of acceleration. So now let's solve question 10. Okay, before we solve question 10, let us first see our velocity. Okay, a particle P moves in a plane in such a way that at any point in time, the distance from the fixed point, that's our radius, is equal to AT plus BT squared. Okay, and the line connecting O and P makes an angle. Our theta is equal to CT to the power of 3 over 2 with a fixed line OA. We should find the radial component of acceleration. Okay, we should find the radial component of velocity of the particle at time is equal to 1. Our radial component of velocity is dr dt. That's all we're supposed to find. Dr dt is going to equal to the derivative of at plus bt squared dt, which is equal to the derivative of at with respect to time plus the derivative of bt squared with respect to time. The derivative of at with respect to time is going to equal to a plus The derivative of bt square with respect to time is going to equal to 2bt. Remember, b here is constant, so you can just factor that out as b, and a is constant, you can just factor that out as a. The derivative of t with respect to time is just going to be 1, because if you have dx, it's just going to be 1. The derivative of t square with respect to time is going to be 2t, because remember, if you have the derivative of x square with respect to time, with respect to x, it's going to be 2x, so there is going to be 2t. 2t times that will be 2bt. So the derivative of r with respect to time is equal to a plus 2bt. But they said at time is equal to 1. When t is equal to 1, then this is going to equal to a plus 2b bracket 1, which is equal to a plus 2b. So these are radial component of velocity a plus 2b, option B. Question 10, option B. Question 11, we should find the radial component of acceleration of the particle. The radial component of acceleration, as we've seen here, the radial component of acceleration, AR, is equal to d square r dt square minus r d theta dt all squared. Now, what do we need to get our solution? We need to find the second derivative of r with respect to time. We need to know our derivative of theta with respect to time. So let's find out our second derivative of r with respect to time. Our first derivative of r, the r dt, was equal to a plus 2bt. Our second derivative of r with respect to time will equal to a will return to 0 plus 2b. So that is just 2b. Okay? Our first derivative, so let's write it down here. The square r dt square is equal to 2b. Okay, our first derivative of theta with respect to time, that is the theta dt, is going to equal to the derivative of theta is equal to c t to the power of 3 over 2 dt. C is a constant, so you can bring it out as c times the derivative of t to the power of 3 over 2 dt. If you are differentiating, remember, bring down the power, that will be 3 over 2c, then subtract the power, the remaining power by 1. So that will be 3 over 2 minus 1, which is 1 over 2. So this is equal to 3 over 2c, this root t. 3 over 2c root t. So this is 3 over 2c root t. So our radial component of acceleration, AR, will equal to the square r dt square, which is equal to 2b, minus our radial component, or our radius, which is at plus bt square, times our derivative of theta with respect to time, all squared, which is 3 over 2c root t all squared. This is equal to 2b minus at plus bt square times 9 over 4 c square t. Remember, this is at t is equal to 1. So this is all when t is equal to 1. When t is equal to 1, this is equal to 2b minus a plus b times 9 over 4 c squared. You can factor out 9 over 4 c squared from both sides, or in this case, they factor out only 1 over 4. So let us factor out 1 over 4 from these both sides. So we have 1 over 4 is equal to 1 over 4, bracket open 8b, minus bracket open a plus b times 9c squared. This here can be oh shit, I'm talking about it. Okay, this here can be simplified to be 1 over 4 times 8b minus 9c squared times a plus b, which is option B. Yes, option B. Question 11, we have option B. So I will let that be seen. You have a radial component of acceleration. Our radial component of acceleration, yes, is the second derivative of our radius with respect to time minus our radius times the first derivative of theta with respect to time all squared. We got them individually, but I've cleaned that part. We got them individually. The second derivative of r with respect to time was equal to 2b. The first derivative of theta with respect to time is equal to 3 over 2c with t. If you plug that in, you're going to have 2b minus at plus bt square. At plus bt square will go from our radius. Our radius is equal to at plus bt square. At plus bt square times 3 over 2 c root t all squared. 2b minus at plus bt square times 9 over 4 c square t. And I've already put the square in the bracket, so that will be 9 over 4 c square t. And remember, they say that at time is equal to 1, so you put in time is equal to 1. All the time, all the t's, you change them to 1. So you have 2b minus a plus b times 9 over 4 c squared. And you have to put them in the form that was given the options. You can leave it like this if you wish, or you can also expand the bracket if you wish. But remember, you have to put them in the form that the option came. To put in the form that the option came, you have to factor out 1 over 4. To factor out 1 over 4, you're going to have 8b minus a plus b times 9 over 9c squared. Simplify it further again, you're going to have 1 over 4 times 8b minus 9c squared. Bringing out the 9c squared to the front, you have 9c squared times a plus b. So that's basically the answer to this question, option B. So let's go on to question 12. Question 12 now has now talk with the transverse component. We're beginning with the transverse component of velocity, which is equal to r d theta dt. So our transverse component of velocity, v theta, is equal to r d theta. The theta dt is equal to 3 over 2c root t, as we have got it from here. So this is going to equal to at plus bt squared times 3 over 2c root t. This is at time is equal to 1. So this would be equal to a plus b times 3 over 2c, which is equal to 3 over 2c times a plus b, which is equal to option 3 over 2c times a plus b. 3 over 2c times a plus b is option A. Question 12, we have option A. 3 over 2c times a plus b. That one is actually simple. So now let's find our transverse component of acceleration. The transverse component of acceleration, a theta, is equal to 2 dr dt times d theta dt plus r, the second derivative of theta with respect to time. Dr dt is equal to, we've already solved that before, dr dt is equal to a plus 2bt. The theta, okay, the second derivative of theta with respect to time, let's find that out. The second derivative of theta with respect to time, that will be 3 over 2c, the derivative of t to the power of half with respect to time, which is equal to 3 over 4 c t to the power of minus 1 over 2. So our second derivative of theta with respect to time is equal to 3 over 4 c t to the power of minus 1 over 2. Yep. So these are the four things. We have the r dt, theta dt, we have the square theta dt square. Okay, we don't need this one anymore. But these are the three things that we need. So now let's solve for our transverse component of acceleration. We have 2 times the r dt is equal to a plus 2bt. The theta dt is equal to 3 over 2c root t plus our radius is at plus bt square, and the second derivative of theta with respect to time is equal to 3 over 4 c t to the power of minus 1 over 2. Remember that all this is when time is equal to 1. So you replace all the t's with 1. So this equals 2 bracket open a plus 2b times 3 over 2c plus a plus b times 3 over 4c. 2 here will cancel out the 2 that is here. So you have a plus 2b times 3c plus a plus b times 3 over 4c. I can factor out 3 over 4c from both sides. If I do that, I will have this is equal to 3 over 4c bracket open 4a plus 8b. The reason why it's 4a plus 8b because remember we're factoring out 3 over 4c, but here it's only 3c. So since we're dividing by 4, we're going to also multiply this by 4 to cancel out. So no, we're dividing by 4, so we're going to multiply by 4 to cancel out. So you have 4a plus 8b plus a plus b. The reason why here I'm not multiplying anything because it's already 3 over 4c. So you know, whatever I'm not multiplying anything, whatever you put out have already been completely put out. So you're not one. I basically just going to multiply by 1 to cancel out. So you're not remember anything. That's just a plus b. So you have 4a plus 8b plus a plus b. That will simplify to 5a plus 9b. So our transverse component of acceleration is going to equal to 3 over 4c times 5a plus 9b. 3 over 4c times 5a plus 9b, and that is B, option B. 13, option B. 13 is option B. And let's go to question 14 and question 15, the final two questions in this video. Okay, for this question, we are giving our vector R. Our vector R is equal to t to the power of 3 plus t squared I plus cos t plus sine square t j plus e to the power of t plus ln t k. And we're asked to find our velocity. Question 14, we're asked to find our velocity. Remember, our velocity is equal to the derivative of our radius, our vector with respect to time. So this is equal to the derivative of the I component is going to be 3t squared plus 2t I plus the derivative of our j component will be minus sine t plus 2 sine t cos t j. 2 sine t plus 2 times 2 sine t cos t is simply as sine 2t. I'm very sure you still remember what they taught you in maths 111. So this will be equal to sine 2t plus differentiate e to the power of t, I have e to the power of t. Differentiate ln t, I have plus 1 over t k. So you have 3t squared plus 2ti plus, okay, you can rearrange this to remove the negative from the front. You can put sine 2t in front minus sine t. So the negative will not be in front. Sine 2t minus sine t. So you have 3t squared plus 2ti plus sine 2t minus sine t j plus e to the power of t plus 1 over t k. 3t squared plus 2t, that is option A. 14 is option A. Let's go to question 15. Question 15, okay, for question 15, we will need our question 14. So we will not need to differentiate again. So question 15, we have to differentiate our answer in question 14. So in case you don't get question 14 correctly, you'll not be able to get question 15 correctly. But you need your solution for question 14 to be able to get your question 15. So question 15 is how to find our acceleration. And to get acceleration, you need to differentiate your velocity because acceleration is derived from velocity with respect to time. So now since we've already gotten our velocity from question 14, we'll just differentiate our answer in question 14 again and we'll get our acceleration. The same way we differentiated, that's how we're going to differentiate now. So let's differentiate our I components. If we differentiate our I components, we have 60. Our acceleration is equal to our acceleration is equal to the derivative of the velocity with respect to time, which is equal to 6t plus 2I plus differentiate sine 2t. We have 2 cos t minus cos t j plus e to the power of t. If you differentiate 1 over t, you're going to have minus 1 over t squared k. And this corresponds closely to option D, 6t plus 2I plus 2 cos 2t minus cos tj plus e to the power of t minus 1 over t squared k. The option here is plus 1 over t squared k. So option D is wrong, and option D was the closest option. So the answer for this question is going to be E, none of the above. So question 15, yes, none of the above. So that means that's the end of this test review. I'll check the exam questions. Okay, I don't know if you saw that in the part, but that brings us to the end of this test review. We'll see if we can do the exam review now, or if I will hold that till later. I'll check how much data I have left to see if I still have energy or strength to continue with the exam on. But if I don't have energy to do the exam on, because we cover some extra topics after the test. So in case I don't do the exam test review, you can meet me personally because after today, I'm not going to do anything on Maths 1, 2, 3 again. Because I have to read for my GST 1, 2, 3. So after today, I'm not doing anything on Maths 1, 2, 3 again. So in case I don't do the exam review today, then you people can meet me personally and I'll explain for you whatever needs to be explained in the topics, for only the topics that we did after the test. Because right now in this video, I now have explained all the topics that we did concerning test 1 and test 2. I've explained them fully. So you can meet me for the ones that we did after the test if I don't do the exam review. But if I do the exam review, then you have to watch this video. So then, so thank you for everybody that joined. Thank you for watching. Thank you for your support. That brings us to the end of today's video. And bye bye.
Hold on.
My team is good.
Yes.
My team is good.
Yeah. So you saw everything.
Yeah, for the test. This for test.
So what everything for exam?
Plus I'll check. No, thing that I wanted to do for last year's because I'm going to use that last year's question. I wanted to do last year to do for the test 1 and test 2. But when I checked the test 1 for last year, mistakes stroke. Mistakes stroke. I always gonna miss Mr. Ogon. He said it was not that said the question. I was like, I had they pass this through the math department he threw the ad. They didn't stop the test or something. And that last year,
you don't check test actually.
Don't check test. Because that last year, I was like, because Mr. Boy used to do this none of the above in case there's no answer. None of the above. But there's also none of the above in the other place. So I was confused. Now, Mr. Boy, it's not that I said this question. He there's nothing that was the teacher then. But so, I not the test. So I'll check the exam and see if there was plenty mistakes in the exam. If there's plenty mistakes, then there's no because.
And what you do is, even if there's mistake in the options, just show them the solution and explain to them why the right option is not there.
I don't know about finish because this test and I did 2 hours. Except if the exam I'm not going to explain fully. In the exam, I'll just give you the tips and move on to the next question. Instead of solving the foots, just give them tips.
Exam, right?
Yeah, for the exam. I'll do the exam. No.